Hey guys, Dr. Brown here, and tonight we're looking at partial fractions. And behind me, I've tried, and don't let your hair fall out looking at this, but since I'm a rules guy, I thought, hey, why not let's do the rules associated with partial fractions, because I know some of the TSU students right now are dealing with partial fractions. So, at least for the ones I normally work, there's 4 rules associated with partial fractions. You know, it's the quotient associated with 2 polynomials. So having said that, there's a methodology for linear, a methodology for repeated linear terms, quadratic, and repeated quadratic. If you can get these 4 things down pat in your mind, hey, you're on your way. All right, so I've given an example here. If you factor the denominator and you end up with something, 2 linear terms in this case, I have the integral of 1 over x times x minus 1. You can put those into 2 fractions. In this case, a over x is the integral of a over x plus b over x minus 1. That's simple. Okay. If I have a repeated linear term, in this case the x minus 1 is squared. Okay, I still take the a over x plus b over x minus 1 and then c over x minus 1 squared. So for every power of the repeated term, you're going to have a partial fraction. Now you end up solving for a, b, and c, and we'll show you how to do that in just a moment. Quadratic, now in this case I have a mix. I have a linear term and I have a quadratic term. So the linear term, same as up here, the integral of a over x plus bx plus c over the quadratic term. If it's repeated, it's the same as in the linear. You need to have a partial fraction for every power associated with the quadratic term. So in this case, we have the integral of dx over x times x squared plus 1 to the 2nd power. Now my a over x is the linear term here, but the quadratic portion, you'll see I have a bx plus c over x squared plus 1 to the 1st power, then dx plus e over x squared plus 1 to the 2nd power. So I have 4 examples here, and hopefully my sound is going okay. I've had some cable troubles. All right, for the linear, we had a video just a few weeks ago. Let me turn my camera here. For the linear, this was the problem we worked. We have the integral of x squared minus 5x plus 6 dx integrated on x. We factor that, the denominator, and we end up with the integral of 1 over x minus 3 times x minus 2, still integrating on x. So I separate those into 2 linear partial fractions, a over x minus 3 plus b over x minus 2. Now there's an algebraic piece to this. Let's take that fraction that we have here that we factored, and we still have the a over x minus 3 plus b over x minus 2, but we're going to multiply every term by x minus 3 times x minus 2 by this. Now when I do that, obviously all of this cancels and I'm left with only 1. In this one I'm left with a times x minus 2, and in this case I'm left with b times x minus 3. The goal here is just to pick a number and solve for a and b. Now in this case, if I let x equal 2, this goes away. 2 minus 3 is negative 1, So negative 1 times b. So negative b equals 1, or b equals negative 1. So negative, I would put that negative 1 right here. Now if I let x equal 3, 3 minus 3 is 0. This side goes away. 3 minus 2 is 1. 1 times a is a equals 1. So I would have 1, the integral of 1 over x minus 3 minus 1 over x, minus 2 dx. And I would integrate those. I would assume by this time in your calculus career, if you're getting to the point of partial fractions, you would know how to integrate that. Okay. What about this next one? Repeated linear terms. Okay, I have this integral of 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Now I should say at this point, you recall our tools, UTI, PP, LC, U sub, trig sub, integration by parts, partial fractions, power reduction, long division, or complete the square. That's 7 basic categories that if you can master those, you're probably going to make 90 on every test you take in Calculus 2. But the long division piece, if this, let's say this term was x to the 4th, and the bottom, the denominator is x cubed, the numerator of a higher power, then I would use long division to simplify this before doing anything else. Now that's not the case here, so I'm going to factor the denominator, pull an x out of it. I get x times the parentheses x squared plus 2x plus 1. Factoring that, I now end up with x times x plus 1 squared. So it's still a linear term, but it's repeated. So remember the rule. We said if we have a linear term that's repeated, I need a partial fraction for each power of the repeated term. That said, I still have a over x. I'm converting this fraction into partial fractions. So a over x plus b over x plus 1 to the first power plus c over x plus 1 to the second power. Now I'm integrating those. Now obviously if I'm not ready to integrate, I need to solve for a, b, and c. Now again, I'm multiplying every term by x times x plus 1 squared. If I do that, all this drops out and I'm left with 5x squared plus 20x plus 6. So now if I multiply x times x plus 1 squared, the x's cancel, have a times x plus 1 squared. Repeat that same process and I end up with these terms. Now again, I'm trying to solve for a, b, and c. If I let x equal 0, those two terms wipe themselves out. I have 1 squared. A equals 1 squared. So a equals 6. Again, my 6 then would go right here. And then just keep working through until you can solve a, b, and c. Quadratic terms. Let's see, we have 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4. I can pull an x out of this term and I end up with x times x minus 1. So those are linear terms. I know how to handle those with a over x plus b over x minus 1. The quadratic term, cx plus d over x squared plus 4. You're going through the same motions. You're going to multiply all of these terms by the denominator you've just factored. Again, it cancels everything out. I end up with 2x cubed minus 4x minus 8. And then a, b, and c here. And it's the same process. Choose a number. What would be a number here? 0. X equals 0 wipes out this. Wipes out that. I'm left with negative 1 times 4 is negative 4. negative 4a equals negative 8. So I can solve now for a and then choose a number, like if you want to get rid of this one, let x equal 1. And then you can work your way through. Now, quadratic of repeated quadratic terms. In this case, we have the integral of 8x cubed plus 13x over x squared plus 2 squared. So I have a repeated quadratic term. So I have to have a partial fraction for each of the powers of that quadratic term. So I have ax plus b over x squared plus 2 to the first power plus cx plus d over x squared plus 2 to the second power. So again, I'm multiplying every term by x squared plus 2 squared. That wipes out at here. I end up with 8x cubed plus 13x. And keep going with that. This x squared plus 2 squared over x squared plus 2, that wipes out one of those. So I'm left with ax plus b times x squared plus 2. And in this case, the x squared plus 2 squared cancels in the numerator and denominator. I'm just left with cx plus d. So in this case, I FOILed out this and ended up with ax cubed plus 2ax plus bx squared plus 2b plus cx plus d. Now I expanded this term. I have 8x cubed plus 0x squared. I don't have an x squared term, plus 13x plus 0. I don't have a constant here. So you'll notice I have only one cubed term here and one cubed term here. So my 8x cubed equals ax cubed. Divide both sides by x cubed, a equals 8. I have 0x squared terms. So b has to be 0. Hey, we're rolling here. Now I have 13x equals 2ax plus cx. Well, I already know a, so I can solve for c readily. C is negative 3, and then d was the only constant. Well, 2b plus d, but b is 0, so d has to be 0 also. And that, I would then take those terms. I have, where's my, here we go, ax plus b, a, 8x plus b, which was b was 0, over x squared plus 2 raised to the first power, minus, which cx plus, so cx plus d over x squared plus 2 squared, cx negative 3, and d was 0. So then you just perform the integration on those, and that would provide you a solution for this integral. And that's the 4 rules. Okay? Let me turn my camera back around again. That's the 4 rules. You got linear, repeated, quadratic, repeated quadratic. And memorize that form for each one, and that will allow you to work through some problems that otherwise, how would we do it? Okay? Why are we doing this? Hey, to build a better tomorrow and do that through math. That's all for now, and we'll talk to you next time. Keep studying. Thanks.